In this question, it is given that if the coordinates of P are transformed to 4, minus 6 root 3. So let's say this is P dash. So P is the original coordinate and P dash is the transformed coordinates when the axes are rotated through an angle of 30 degree in the anti-clockwise direction. And here we are interested in the coordinates of P, that means original coordinates. Okay, so let's first understand this particular situation visually. This is original x and y axis and we have rotated both the axes by an angle of 30 degree in anti-clockwise direction, just like this. This is capital X, this angle is 30 degree. Yes, and this is capital Y. And in this transformed axis, the coordinates of P dash are nothing but 4, minus 6 root 3. This is denoted by capital X and capital Y. And here theta is equals to what? 30 degree. So now we want to understand the relation between the original coordinates and the final coordinates. Original coordinates are denoted by, let's say, x, y, coordinates of P, which we are interested in, and P dash is the capital X, capital Y. P dash is the final transformed coordinates, which is already given to us. Okay, and the relation is this. This is small x, original coordinates. This is capital X, which is 4 in this particular case. Capital Y is minus 6 root 3 in the case, and theta is nothing but 30 degree, which is anti-clockwise angle. Okay, so let's put the value over here. Small x will be what? 4 cos 30 degree minus 6 root 3 sin 30 degree. Yes, similarly, we just need to solve this to get the value of x. Now, similarly, the value of y will be given by this formula. Y is capital X sin theta plus y cos theta. Let's put the values. Y will be what? 4 sin 30 degree plus, okay, minus 6 root 3 cos 30 degree. We just need to solve this to get the final answer. Now, this will be what? 4 root 3 by 2. Yes, that means 2 root 3. And what about this? This will be what? Plus sin 30 degree is 1 by 2. So, this will be 3. So, 3 root 3. That means 5 root 3 is the x coordinate. Now, let's calculate the y coordinate. Y coordinate will be, this is 1 by 2 and this is 4. 4 into 1 by 2 is 2. Minus 6 root 3 multiply root 3 by 2. Which will be what? 2 minus 9, that is equals to minus 7. Y coordinate is minus 7. So, the original coordinates of P will be what? 5 root 3 comma minus 7. That means option C is absolutely correct answer. Okay. In this question, we need to determine the locus of this particular point P, which is cos square t comma 2 sin t, where t belongs to R. Okay, so let's first understand one thing, that whenever you need to find out locus of any point, you just mark that point as h comma k. Okay, so let's mark this h is equals to cos square t and k is equals to 2 sin t. Yes, and we want to find the locus of point what? H comma k. Okay, that simply means that we want to eliminate this parameter t from these two equations. Are you getting my point? Now the focus is all about that we want to eliminate this t somehow. So what do we know about cos t and sin t? How to eliminate the terms, the equations related to cos t and sin t? Well, the answer is very, very simple. We do know a relation between cos square and sin square, which is nothing but cos square t plus sin square t is equals to 1. Now we just need to put the values of sin t and cos t in this equation. T will automatically get eliminated. Let's see how. So here cos square t is h. So simply I'm going to put h in place of cos square t. But what about sin square t? For that we need to know the value of sin t from the second equation. This is first, this is second, okay. So second equation says that k by 2 is the value of sin t. If I square, I'll get the value of sin square t. That simply means that k square by 4 is the value of sin square t, and this particular value is nothing but 1. And the moment you get the relation between h and k, which is free from parameter t, this is the locus itself. This particular equation will give you locus of point P. You just need to replace h by x and k by y. If you do that, what will you get? Y square by 4 plus x is equals to 1. If you simplify this, what would you get? Y square plus 4x is equals to 4. This is the locus. Yes? Now, Option D. I can clearly see that option D is the correct answer for this particular question. Okay? In this question, we need to figure out the intercept form of this particular line. And we already know what is the intercept form of any line. X by A plus Y by B equals to 1. Where if this is x-axis, this is y-axis, and this is the straight line, yes, then this would be what? X-intercept, which is equals to what? A. This would be y-intercept, which is equals to what? B, with sign, okay? So we just need to tell the equation of this line in this particular form. For that, what I want is 1 on the right hand side. So let's make constant on the right hand side 3x minus 4y is equals to minus 12, right? Now to make this right hand side 1, what we want to do is divide everything by minus 12. So 3x by minus 12 minus 4y upon minus 12 equals to 1. 3 ones are 3, 3 fours are 12, 4 ones are 4, 4 threes are 12. So x by minus 4 plus y by 3 is equals to 1 is the final equation, which is exactly matching with option B. Easy question. So finally option B is the correct one. Got it? In this question, it is given that P1 and P2 are the lengths of the perpendiculars from the origin to these two straight lines, and we are interested in the value for P1 square plus P2 square. Okay. The moment I read this line, lengths of perpendicular from the origin to straight line, this particular portion, lengths of perpendicular from origin to the straight line, automatically normal form of the equation comes into picture. So these are the two given line 1, line 2, and the normal form of any equation is given by x cos alpha plus y sin alpha is equals to P, where this is the straight line. If this is the straight line whose equation is this in normal form, then P is nothing but perpendicular distance from the origin to the straight line. This is P, and alpha is this perpendicular making with the positive direction of x-axis. This is the whole situation. Okay. Normal form and this picture both comes hand in hand together. Okay. So you need to remember this particular situation with respect to this form always. Now, the idea is to calculate the P of this equation and this equation, because as per the question, P is what? P1. Actually, P1 is what? The perpendicular distance from origin to this line. This is P1. And P2 is what? Perpendicular distance from origin to this particular line. So here we are trying to convert both the equations in normal form and then eventually calculate P, which is perpendicular distance from both lines. So P1 will be perpendicular distance of the first line and P2 will be the second line. Got it? Now, let's focus on first line. This and this. We need to compare this. So what I can see over here it is sec theta and here it is cos alpha. Okay. So we need to convert this equation. We need to do such manipulation such that there is cos in place of this sec by anyhow. Okay. So what I'm going to do is I'm going to write sine and cos in place of sec and cosec. So I'm going to convert. So sec is 1 by cos theta. Yes, and this will be 1 by sine theta and this is equals to A. And if I take LCM, what do I get? X sine theta plus y cos theta is equals to A sine theta cos theta. Cool. But wait, X has sine theta. But I want cos in multiplication with X, isn't it? So what I'm going to do over here is write X cos 90 minus theta in place of X sine theta. Yes, now we have cos in place of sine. Yes, and similarly, if this is replaced by pi by 2 minus theta, I'm going to replace this by y cos what again? Okay, y sine pi by 2 minus theta. So y has sine as a term. So here alpha, if I compare this normal form with this equation now, pi by 2 minus theta is alpha. Okay, and on the right hand side, what do I have? Same thing, a sine theta cos theta. And if I multiply 2 and divide 2 on the right hand side, what do I get? A sine 2 theta by 2. isn't it? A sine 2 theta by 2. Now, if I compare this equation with the normal form, what do I get? I clearly can see this is P of first line. Isn't it? On the right hand side, we are left with just P, and P is perpendicular distance from the origin to this particular straight line. So P1 in this case will be what? A sine 2 theta by 2. P1 is sorted. In similar manner, we need to talk about straight line number 2. So here it is already cos theta is sorted, but here it is minus sign involved. Okay, and sine theta is also sorted. So I'm going to adjust this minus sign over here by taking it inside the sign. So why sine minus theta? Because minus sine theta we already know is sine of minus theta. But wait, here it is cos theta and here it is sine minus theta. That will not work because in this form the argument inside the cos and sine are same. So what I get to do over here, cos minus theta is cos theta. So I'm just applying a minus sign. It will not affect my equation at any cost. So x cos minus theta plus y sine minus theta now can be written as a cos 2 theta. And this is nothing but P2. Perpendicular distance from the origin to this particular line number 2. So now we have P1 and P2. P1 is a sine 2 theta by 2. P2 is a cos 2 theta. Now we are interested in this value, 4P1 square plus P2 square. So 4P1 square, okay, which is sine 2 theta by 2 whole square plus P2 square will be cos 2 theta. And we have a over here. Let's not forget a, okay. Now if we solve this, 2 square and 4 will get cancelled out. A square is getting common from both the terms. Sine square 2 theta plus cos square 2 theta. Do I need to say it as 1? That means the final answer of this particular question is option C. Okay. In this question, it is given that a line is passing through minus 5, minus 4, meets 3 lines, let's say L1, L2 and L3 at points B, C and D respectively. If this equation involving AB, AC and AD distances is true, then we are interested in equation of this particular line. Now this question is of parametric equation. Yes, application of parametric form of equation. Now you will ask that how to understand that this question is purely based on parametric form of equation? Yes. So I have an answer. Let's first visualize this situation. So as per the situation, this is the diagram. We have a point A which is minus 5, minus 4 and we have 3 lines L1, L2 and 3 whose equations are already given to us. Okay. And a line is passing through A, intersects these 3 lines L1, L2 and L3 at point B, C and D, and we have a given information which is this, which involves what? AB distance, okay, AC distance and AD distance. Okay, so in this particular question is a point is involved. We are interested in equation of a straight line whose point is already given to us. Okay, if a point is given to us, that simply means that we want slope of this line, which is tan theta we are interested in. Okay, so that is one. To get the tan theta, we will solve this by using parametric form of the equation of straight line. Okay, so here a particular direction of this line is given to us and is in the same direction 3 distances AB, AC and AD are involved. Remember, the point and distances collectively are there exactly in parametric form of equation, which is this: x minus x1 by cos theta is equals to y minus y1 by sin theta is equals to r. Here x1 and y1 are the points on the line, cos theta and sin theta. Here theta is the inclination of the line or direction of the line, and r is the distance of point x comma y, which is this, to x1 comma y1. X comma y is any point on the line. Okay, remember the distance of x comma y, unknown point, to this known point is nothing but r. And in this particular situation, same scenario is getting created. If I assume this point as x comma y, this will automatically x1 comma y1. Yes, and this AB will be r in this case, and the direction of this line will be same. Similarly, if I talk about AC distance will be r in this case, and this point, unknown point, is obviously movable point, and AC will be the distance and x x comma y and x1 y1 are there, and direction is again what? Theta. Inclination is theta. Similarly, if x comma y is this point, then the distance will be AD. Okay. So here, by changing the distances, if the distance is AB, then x comma y will represent what? X comma y will represent coordinates of point B. Okay. If I change the distance as AC, so x comma y will represent coordinates of point C. And if I change distance as AD, x comma y will represent the coordinates of point D. Okay. So if I talk about x comma y, if I calculate the value of x comma y from this expression, what do I get? I get x minus 4 by cos theta is equals to r, and y minus y1. That means, okay, so this is x plus 5. And this is y plus 4 by sin theta is equals to r. Okay. And if I calculate the value of x, it will be r cos theta minus 5. And what? R sin theta minus 4 will be the value of y. Or let us write it as minus 5 plus r cos theta. Okay. And minus 4 plus r sin theta. Okay. Now listen to me carefully. This x comma y will represent the coordinates of B. This x comma y will represent the coordinates of B if this r is equals to AB. And this x comma y will represent coordinates of C if r is equals to AC. Similarly, it will represent coordinates of D if r is equals to AD. And AB, AC and AD, all the three values, all the three distances are involved in the given information. Okay, so let's talk about point B now. Let's talk about point B. So point B will be what? Minus 5 plus AB cos theta comma minus 4 plus AB sin theta. Isn't it? And this coordinates of B is lying, point B is lying on line L1, and we already know the equation of line L1. So why not satisfy this point in line L1? Similarly, if I talk about coordinates of C, it will be similar, minus 5 plus, now R is being replaced by AC. So AC cos theta comma minus 4 plus AC, this time sin theta. And now we know the equation of line L2 and we know the coordinates of point C. So why not satisfy this coordinate in L2? Yes, we'll do that. And similarly, coordinates of D will be what? Minus 5 plus AD cos theta comma minus 5 plus AC AD sin theta. And we do know equation of L3 as well. We'll satisfy these coordinates in L3. Okay, so we'll have three equations. Cool. Let's do that. And then we'll see what is given actually. So here L1 is this and coordinates of B is this. Okay, and B is lying on L1 as per the equation, as per the diagram. B is lying on L1. So we'll satisfy this B in L1. If I do that, what do I get? Okay, let us do over here. So satisfying B in L1, minus 5 plus AB cos theta plus 3 times minus 4 plus AB sin theta plus 2 equals to 0. Let's quickly solve this. Minus 5 and this will be what? Minus 12, that is minus 17 plus 2 is minus 15. Okay. So minus 15 plus, in these two terms, what I can take common is AB, of course. And inside this, I'll be left with what? Cos theta plus 3 sin theta, which is equals to 0. Now, what do I get? From here, I'll be getting 15 by AB is equals to cos theta plus 3 sin theta. Equation number 1. And given is 15 by AB whole square. Okay. And I have reached till this point, 15 by AB automatically. Cool. Similarly, if I solve this, if I talk about satisfying C in L2, what do I get? I'll get 2 times minus 5 plus AC cos theta plus minus 4 plus AC sin theta plus 4 equals to 0. Cool. If I solve this, what do I get? Minus 10. Okay, minus 10. Minus 4 and plus 4 will get cancelled out. Minus 10 will be equals to what? 2 cos theta plus sine theta. And yes, minus 10 is equals to, and an AC involved over here. Or rather, let me write it as 10 by AC is equals to 2 cos theta plus sine theta. Yes, 10 by AC is equals to 2 cos theta plus sine theta. This is equation number 2. Let's talk about D. Coordinates of D are there and we do know equation of line L3. Let's satisfy D in L3. If I do that, what do I get? Minus 5 plus AD cos theta minus 5 minus y. Okay, so minus y. So plus 4 minus AD sine theta minus 5 equals to 0. Constant terms, minus 10 plus 4. Minus 10 plus 4 is minus 6 plus AD cos theta minus sine theta equals to 0, or rather 6 by AD is equals to cos theta minus sine theta, equation number 3. So now we have 3 equations which are these. And as per the question, it is given that this 15 by AB whole square plus 10 by AC whole square is equals to 6 by AD whole square. So now we know the value of 15 by AB already calculated. We just need to put the value. So if I put the value, what do I get? Cos theta plus 3 sin theta whole square plus 10 by AC already have this 2 cos theta plus sin theta. 2 cos theta plus sin theta whole square. This is equals to what? 6 by AD. So 6 by AD is cos theta minus sin theta whole square. Now, let me remind you, since there is too many calculations over here, so let me remind you that what are we doing actually. So here, this is point A and a line is passing through this point A, minus 4, minus 5, minus 4. This line has a slope tan theta. M equals to tan theta, and inclination is what? Theta. So we are just interested in the value of tan theta or theta. Yes, and the moment I get this tan theta or theta, I can write the equation of this particular line, isn't it? So we are just looking for theta. This whole drama is for theta only. The whole calculation is for chasing theta. So here I can clearly see that the final equation is in terms of theta. We just need to solve this to get the value of theta. Cool, let's do that. Cos square theta plus, okay, if you solve this, what do you get? Cos square theta from here and 4 cos square theta from here. It will be 5 cos square theta and one more cos square theta on the right hand side. So it will be what? Okay, 4 cos square theta. Cool. What about sine square theta? 9 sine square theta from here plus 10 sine square theta and here one more sine square theta. So overall 9 sine square theta. And if you solve for the term related to sine theta cos theta, what do you get? Actually, you'll be getting plus 12 sine theta cos theta equals to 0. This is the final equation. Okay. 4 cos square theta plus 9 sine square theta plus 12 sine theta cos theta equals to 0. Okay. So this is 2 cos theta whole square plus 3 sine theta whole square and twice of 2 cos theta, 3 sine theta is equals to 0. This is nothing but a perfect square of 2 cos theta plus 3 sine theta. Isn't it? That simply means that 2 cos theta is equals to minus 3 sine theta. If you calculate the value of tan theta, what do you get? Tan theta is minus 2 by 3. This is what we were looking for. Slope of the line is minus 2 by 3 and we already have a point. Point is what? Minus 5, minus 4. Slope we have, point we have. Can we apply point slope form to find the equation of this line? Of course, yes. So here y plus 4 is equals to minus 2 by 3, x plus 5. Now we just need to solve this. Let's quickly do that. 3y plus 12 is equals to minus 2x minus 10. Or finally 2x plus 3y plus 22 is equals to what? 0. That gives me, okay, option A as the final correct option. Got it?